All right. Rule number one of sending your VODs to YouTube: always be exporting. Um, yeah, in our last session, we started to run into interesting issues of concurrency. We were finally starting to get our pool of work into grips, and we were starting to think about event-driven architecture in the context of Gas City. So as things are getting worked on, and other agents might want to react to work getting done and pick up from there. Um, the publish and subscribe of an event-driven architecture starts to appeal. So instead of listening for 250 beads, maybe we're listening for a batch to get completed, and we subscribe to a batch completion event and then start doing something after that. Um, so, for instance, the one we were looking at was quality checking a sample of puzzles after 25 or so are brought into the catalog. Um, but the other thing that we were working on was concurrent writing. So we have a setup right now that isn't concurrency safe, since we've just got files on disk, and we're have potentially multiple writers writing into the same file at the same time. Um, we have ways to solve this in software and the industry in general, but they are more complicated, heavyweight to run, perhaps. Like instead of writing files into a file system, we might be writing rows into a database table, and that requires us to be running a database and all this stuff. We could use local ones, like SQLite might be a good proxy, for in lieu of running a completely remote service and having to deal with its outages and all that come with distributed systems. SQLite is sort of like a mini version of that that's much less likely to go down. Everything's, resident on disk, very, very fast, that kind of thing. And we could expect some of our concurrency controls. All right. Well, once we came up with those questions on concurrent work, pooling, event driven architecture, and such, we shipped off a big mail to the GC Oracle, one of our agents that looks at Gas City source code for us and then tells us the right way to do things, that kind of thing. So let's see what was said. Okay. Um, it's probably separate. We're doing things. There's a lot of cruft. Um, as we're going through, we're making systems or trying stuff. We're sending work that never going to get completed and discovering bugs, that kind of thing. All right. It's sort of weird to me that I'm not seeing. Sometimes we'll see the session react to getting mailed and then update me and that kind of thing, but it hasn't done that this time. Like if it were just checking its mail every 5 minutes, we would probably have seen um, this kind of thing already appear inside of our log. All right, let's give it a minute. Army ants. We were trying to figure out army ants. I think we figured out some of it, right? Like we figured out that and then right. So we were talking about how we figured out that there were going to be three chains because we could count the numbers of ones, twos, and so on in the puzzle. That indicated we'd have a short chain, we'd have a longer chain, and we deduced that this was the only way to construct it over on this side. And finally, we've got to figure out which one is going where, and that hinges on where this 5 is going to go. I think we can actually tell that putting the 5 here is not going to work because the best we could do is have the 3 sort of reach up here. It wouldn't reach these two squares, and that means these two couldn't interact with it. So the only real candidates left are here and here. I think we've got to send the 5 right here. That implies that we've got to send the 4 right here and the 3 right here. No other way the 4 can touch the 5. And we have nowhere left to put the 3. That can also touch this 2. Then the 1 doesn't move. So now we're just left with, can we draw paths that don't overlap to get them to these places? And of course I feel like we do, and you could kind of see that on the solution as well, if you kind of remember how it looks. Obviously they were able to do this, no big deal. Yeah, so this is, I think, our solution. Yeah, all right. So that's how army ants works. Yeah, not bad. Here, I'll save these, and we can close a few. So yeah, when we're not working with the mayor, we're looking through the great puzzles. Have a system for reading all your mail. I would think that is important, and we shouldn't need to nudge every time we send mail. Sending the mail is the nudge. Now it's got me writing like it. Okay, so we looked at army ants. As I mentioned, we're going through, there's a list of Nikodi puzzles in this encyclopedia uh, by Yanko, Anna and Otto Yanko, if I remember right. Anna and Otto. Um, Hopefully I got that right. Oh, and these appear to be editions of Nikodi. Not that I have, read them all or anything like that. But yeah, again, no big desire to like take others' work, just a big desire to learn from it and enjoy the puzzles. Number link, Aru Kone. We're very familiar with this one, and this is documented in English, so we've already done it on the stream. Bonds, Barnes. Draw a single closed loop in the grid, which goes once through each white cell and once or twice through each gray cell. You can't cross walls, those little black things. We go between center points as usual. In white cells, may turn at right angles but not cross itself. In gray cells, cross itself but not turn. Oh, well, this is much like ice. Which one is it? Ice barn. Aren't they the same? uh, but with walls. Yeah. And so these are our patches of ice, and we have to go straight across them. If we know that we have to go through every square, then that opens up some stuff too. Okay. Okay. Let's see if the mayor answers here. Um, Sure. Let's sure. Is this a gas city bug or an artifact of the way we are dispatching work? We can file a deed to resolve it either way. That's sort of another question for the GC Oracle, right? It's like, am I doing this wrong? All right. As I mentioned, we've got some ice skates. Let's keep on using ice skates and red for blockers. So we have these. I guess we've got all these gray areas now. Oh, blue. Show up a little better. So we're gonna have some like blue and red. Green? Red, green. That shows up a little bit better, I would say. Like I said, we know we need to go through everything. And we know that once we start, we just can't stop. Go. This section is kind of on rails up to here. Oh, there's no entry and exit either. So since we're making a loop, we can start and end kind of anywhere. There's no law, I think, that says that we have to cross all the pieces of ice both ways. It's just an option. It's a may. Once or twice. Still waiting for the oracle to reply, which again, it's fine. Only one way through these corner ones. Zoop. All right. And we can lay some blockers if we want. Right. I mean, it's sort of a no branching kind of thing. It'll get more helpful if we ever eliminate a side of ice from being used. Then we can sort of eliminate the opposite side because we'll know that we can't slide through there. For instance, if there's a wall on the other side of the ice, then we can't enter it from this side. Then that makes a little corner on this white cell. There's a similar observation we can make right here. I think those are the only ones, though, where there's a black wall on the border of an ice patch. We were talking a little bit earlier about doing reads off of our different specialists because we were trying to ask the antiquarian what's the status of the catalog progress. And I don't think we've fired off that work yet because we this one could, oh, okay, it actually has to. This one, to get through this white cell, we have to go through this way, then this way. That implies can't go through here. This way, the only way. I guess at the corners, we know we have to go through the corners. This is one that I take from trains. So you notice that we have to go through this cell, and there are only three ways in and out of this cell. But if we pick these two, then we'll make a small loop, and we need one big loop. If we don't pick one of those two, then we have to pick this one. Here's a new corner that was created because we can't branch right here. Corner again. Corner again. Corner again. And now on this one, we have to go, the only way through this cell is to go up and down like so. There's a corner again. Some of these rules are sort of familiar from Perl as well. Of course, I invite you to play along with some of these games. We're trying not to make a loop prematurely. So all of that was forced over there in the corner. To go through this cell, we've got to make another corner. I gotta tell you, there are things that I like about this puzzle. Oh wait, that's an undo. Oh, although now that we've got the path going by these gray, it is kind of creating virtual walls. And we could mark those if we're going to be confused about ice patches and other gray areas. Okay, so that slightly confused me, but now we're sort of back on course. If we crossed here, then we would cause a loop. So we can't cross here from either angle. Let's keep going. There we go. It's not immediately obvious if we're going to be able to make more inferences over here. It's also not immediately obvious if we're stuck over here because we can cross the ice in either of two ways. To get to this, we've got a little corner here now too. We can't branch here and there's a wall here. So we have to go this way and this way. Go to satisfy that as a corner. We can't go to the right because we would branch right here. Another one of those. Don't come this way. Now we'll slide across the ice over there. Now we're kind of looking at loops, and this would make a loop if we connected it right here. So we can't do that. Gotta branch off the other way. Not immediately obvious if we can or can't connect this. Or if we're intended to go across the ice twice or once or 0 times. We'd like to use the risk of making a loop to help us out there a little bit. Here, there's a new corner. Means more this. We're most of the way there. I think we've made most of the inferences that we're going to need. One of the ones I'm thinking of has something to do with the number of entries and exits from a region. So here you can kind of see that we've got 1, 2, 3, 4, 5, 6, 7, 8 dangling ends on this side of the puzzle. So if we did cut this off, say by drawing this line from here to here, the only way for this to escape would be out across this ice. So imagine we had this one. Can't connect up this loop, so we have to go this way. And then we'll have 1, 2, 3, 4, 5 ends inside of this arena with no way to get them out because we've blocked off all the other ways. So that actually doesn't work. We can't have, for every entrance into a region, there needs to be an exit from the region. And having 5 means that we're not going to be able to pair them all up. One of the extra laces or whatever is going to get stuck in there. So we actually have to go like this, and then like this. Oops. How about down? Is that easier to draw? Yes, much easier for some reason. Now we can kind of count. Do we have the right number of laces in the region? 1, 2, 3, 4, 5, 6, 7. It's still wrong. And if we connect to this, it'll still be wrong. There'll still be 5 in this area. And we'll have one sort of cheese standing alone. So we're forced to leave like this. And like so. All right. Can these two be looped up together? Yeah, it would be possible. So if these connected up together, that would imply that these two ends are two ends of the same loop. So they could connect to each other. This one would go like this, and then this one would come up here. Then these two ends would make a big loop, and so we wouldn't connect them. We'd go like this, and that would sort of save that area of the puzzle. Have we got our mail yet? Let's check for an update. It seems like the mayor could check for an update every couple of minutes, and I would be fine with that. That's probably a fairly cheap operation compared to all the hard thinking I'm having it doing. Okay. Feel like the end is nigh on the puzzle. What inference is our left? We're still not sure about these last two skatings over here. We can treat this as a corner, but it doesn't tell us where this end has to go. Okay, that would be helpful. We should be able to count ends, I guess, using this as a border too. With the question being, should I send this to the right or the left? So right now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 ends to the right of this line. So we need to get that 10th one in there. That would look like this. Now we'll be able to satisfy all of our pairs at least. Now I'm just working off of the corners that got created here. All right, so the other questions are we creating any loops that are smaller than the whole puzzle? For starters, if we crossed the ice right here now, I think that is a loop on itself. Yes. So we can't do that crossing of the ice. I have to connect up right here. The same in the other direction. Okay, a little hard to see where all the lines go. But a simplification is that this line, part of the loop, and this part of the loop are the same. They're the two ends of the same thing. These are two ends of the same thing. We've got these ends of the same thing, and these ends of the same thing. So I feel pretty confident we'll be able to work out which goes with which. So here's where sort of hypothesis testing comes in handy. If we did hook these two together, then we'd have the two ends of this loop right next to each other side by side. They'd have to run away from each other, and it seems like it works fine. Do that. This, and this, they have to run away from each other, as I mentioned. And now these two would connect up, so they can't. Till the very end. Here we go. And we can double check this, but we definitely didn't branch. We've gone over some portions of the ice once or twice, and we've been through every cell. So that would be it. That's Barnes. Barnes. I think there was another cycle. There was another development cycle happening between the inventor, analyst, playtester, and Smith. They were working on a test of Slitherlink where you have to visit every cell. So at least one edge on every cell. Is that complete? Or are there learnings to digest? Another capability to add is some interaction. I would like to be able to try test files in a web page context so that we can vet the puzzles and solutions interactively, and perhaps also record my interactions and thoughts on fun. At bare minimum, we should have a user interface. Is there a suitable agent, or should we start to spin that department up? All right. We can try to compare this to our solution. I think it's the same. Oh, no. They did something a little different in this top corner here. I'm not sure I understand why yet. Did I miss a cell or something? I retraced the loop visually. It does make a loop. It does visit every cell, I think. Right? The different part is right here. It says once or twice through each gray cell. So I think this is an issue right here. The fact that we never went through this gray cell. Well, that could take us a minute to unwind. Like we'd have to be unwinding fairly far through here. Let's do fail. Let's load the puzzle again. Wow. Okay. And we can start with the assumption that we messed up here. We have to get through these gray cells, and the only way to do that, like so. Slip. So we'll start with our forced moves. We can't go this way. So we've got to go this way. And we can't go this way, because we would branch on a white. This way. I mean, this is going to feel very familiar. I don't know exactly what I screwed up in this part. When we marked these as can't do, something was off about that. Slipping and sliding down to here. Gotta do these ones in the corner. Oop. Corners. 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 Okay, corners. New corner. Yeah, the requirement to go everywhere does a lot of heavy lifting in this puzzle type. Corner, corner. We got to go through here to this corner. We know we can't go this way to close the loop. Yeah, so like a lot of these inferences are going to feel super familiar. Especially if you spotted my error somehow. Close it up. Got this kind of, at least to here. Maybe this is where the screw up is. It's definitely possible to either close, well, we can't close this as a loop, so it's got to cross through. And this we've got to get through. We can't close this loop. Maybe I just failed to consider an ice possibility. This is certainly simplifying this area of the puzzle. As you'll recall, we made use of some like counting arguments to say we need to have a certain number of ends in here, which was a valid inference, but it was based on some faulty data, I guess. I have to be at least mildly impressed that I got something wrong on the puzzle. The two ends of this right side loop are here and here. So we can't really use that fact yet. This wall and this wall are cut off. So there's a sort of virtual corner there. And we just made one right there. I keep saying corner of the line we're taking. All right. I think we're back in the place where if we crossed, then we would make a loop. Yeah. So we can't cross. We need to join across here. And that's the puzzle again. Did we get it this time? So far, so good. Kind of think so. It's not easy to check this type of puzzle, but just kind of going back and forth and seeing that in a zero knowledge proof sort of way that covered all the bases. Yeah, I don't remember. It'll be interesting to watch back the video and see what caused me to not go into this gray area. Okay. Oh, we got a ship verdict. Interesting. Vertex parity dominates 3x3 endgames. Sure. No branching? That's fine. Four by four reassessment. Recommend a new department. I guess we should always start with the minimum viable. I think that's smart. Yeah, I think so. Let me the first project should be the puzzle. The puzzle viewer. I think the charter for the department should note that it's on path for making these available on the web or mobile. That's the commercial model we observed in Conceptus puzzles. But that's a capability we can grow into over Cool. I think this is a natural thing. I think it would take a very meta mayor to go, hey, I have an overall charter to deliver a certain kind of product, and I feel the need to have these moving parts in it and to stand up the agents I think I need. And if we come across a gap, I'm going to have to expand it so that I can meet my charter. But we're not quite there yet. Presenter. Hmm. I think this is fine for a start. Let's go with it and refine over time and experimentation. Yeah, yeah. I think that's pretty much what I was thinking. Pencils. Yeah, cool. I like how if you they did pencils in different colors. We did do this one. Penshiruzu. Um, I learned the word enpitsu for pencil in Japanese. Okay, border block. So this is something, it's kind of similar to filling, and it's kind of similar to number link, but it's sort of like we're not given the endpoints of the regions, and we are given places where we need to draw borders. So there's no chance that we won't draw at least one of these four lines leading to this dot. I think too that this one on the edge means there's no chance that we won't draw this line to the edge. Um, all branch points of the border lines are given and must be used. Yeah, but it doesn't necessarily mean that we draw from here to here. Maybe we just draw from here to here. Um, okay. Border block. Let's see what we can make out of this. Oh, whoops. Wrong one. Don't really need this right now. Okay. So, for instance, numbers that are in the same region have the same number. Numbers that are different and adjacent are in different regions. So these are like the trivially true ones. And I'm not totally sure I understand the dots. I really think it means that we've got to get at least one line through here. So for instance, we've got to get, there's different ways to do it. It seems like the ones on the edge would be satisfied by the outside of the border, but I don't think so. If so, that means that we would get this one, we would get this one, and we would get this one. Okay, we've got to get the threes to the other threes. So this is where filling is kind of interesting, right? We've got to get the 3 out this way. See, we could add a 3 here, but it still doesn't get us any closer to these ones outside. And that's sort of a dead end. And then we're going to throw our 3 right here. These guys are all together. We can draw a border in between 5 and 3. For sure, they're not part of the same thing. And we've got to let these 5s get out to the other 5s. Only one path for them to go on. And I think that we could assume, unless we're drawing like a new number 8 or something like that, that this is also a 5. We can also just wait on that. So like if we drew a 5 here, there would be no line in between here and here. Probably not. That's probably not right. Okay. So far, simple. All the 5's got to be in a big blob, and we've still got to come out here and meet our 5. Okay. We don't have any more 4's to work towards, or 6's, or even 1's, or 2's, right? Now we're just trying to satisfy drawing these border lines. And it seems kind of unconstrained, but there's probably only one solution. I guess that's what's kind of weird about it. Like, if this 2 met some other number over here, that would work. So we can't have 2 4's, 2 6's, or 2 2's come through here. Or even like a long run of 5's, right? Because then we wouldn't be drawing these lines. Yeah. Let's just draw these from the edge. I think that they are required. Although the rules are a little ambiguous about it. So we're going to have to fill this with a 7 or a 3. It's not super obvious which one is necessary. Maybe if there isn't a dot, there can't be a line. I don't know if that's true. All branch points of the border lines are given and must be used. Branch points. Okay, I think I see. A branch point means that there have to be at least 3 regions meeting. If there are just 2 regions, then that's not a branch point. It only, yeah, so all of the 7 and 3 border, there are no branch points, but 7, 5, and 3, there's a branch point. So why is there a branch point between 7, 5, and the edge of the puzzle? I guess wherever there are 2 borders meeting on the edge of the puzzle, that's a branch point too. So it's sort of treating the outside of the puzzle as another region we want. Okay, does that kind of make sense? So between 1 and the edge of the puzzle, there are no branch points. Between 1, 7 and the edge, there are branch points. This could be a little bit more explicit. I think that would be helpful. Sure, sure. I don't know why GC Oracle hasn't replied. I don't think we've used that much context. I think we started new just, less than an hour ago. We could double check, but no fun. Just do your thing. Okay. So, for instance, we can't have 3 up here because then this wouldn't be a branch point. It would just be an edge between 5 and 3. So if we put 7 up here, then we have this, United Nations meeting. This is a kind of weird puzzle. Um, so defining it as I have, it's like we need two different numbers on each side of this, fair. But we need three different numbers, like a third one coming in here or here on this one. The three closest ones are definitely 7, 3, and 1. Uh, hmm. This could be a 1, 6, 4 area right here. I mean, again, it's about just who's closest. Oh, well, I guess one is that we know that there isn't a branch point on this edge between this cell and this cell. So we can confidently draw in this by the same logic here, here. We know there is a branch point right here, so it's got to be something different than 4. So that's the end of 4. And 6 is the only one that's accessible here. There isn't an edge here. Yeah. Okay, I guess this is a way to sort of think our way through this puzzle. If this were just an edge between 2 and 6, then there wouldn't be a branch point here. We can close that off, and then we need another number. It's probably got to be 5, I think. There isn't a branch point here, so the 5 actually doesn't come here, because otherwise we'd have a three-way branch between 1, 3, and 5. Okay. The 5 doesn't come down here because we do need a branch point here, here. And if 5 was here, then there'd just be an edge between 5 and 2. So that's it for 5. I wonder if this border here implies that we've got to keep doing 3. It kind of does imply that. Go. And then the fact that there's no junction here means 1's not going to come in. We've got to do 6. Continue this wall. Now, I think that the way that we're solving this, we're trying to figure out where the walls go and infer where the junction points are. I might have done that last bit wrong. Because I do need a junction here, which means this can't be a 6. It's got to stop. And I think that if we're following the wall here, if there was a different number here, then this would be a junction point. But that means this has to be right here. We do have 3 here for this junction point, and we can go back and check all of our junction points. They all have different stuff so far. Whatever goes in here is the same all the way along the wall because there are no junction points. There's no junction points along here either. If this were a different number than 7, there'd be a junction point. Same here too. This could be a 3. Because it's just going to have an edge here. If this were a 7 right here, then there'd be a junction point right here, but there isn't. And there's no junction point right here either. So there has to be some continuity. There's no junction point right here. So it's got to be either a 3 or a 1. So far, so good. We can. So if this were just whatever we pick down here, it's got to be the same the whole way. 1 seems to work a little better. Maybe we bring the 3 down here and then 1 for all the rest. I think that would satisfy all of the borders and junction points that we need. Is there any other solution? If this were a 1, then this would be a junction point. So it's not. And now there needs to be a different number right here. So this can't be a 3. There we go. And it can't snake around that way either. The only one that's left that can get there is 1. How about the status of this last one? If we brought a 3 down, there'd be a junction point here on the wall, but there isn't. So there we go. Pretty weird puzzle. Pretty weird idea of junction points too. Oh, good. We finally got back our mail from GC Oracle. We started it says you looked at existing department structures, but there is a formula for onboarding a department. Hmm. Uh-huh. Mayor's call. That's interesting. I'm interpreting the Oracle's responses as saying it has no information to contribute either way. I'm a little surprised that the structures in Gas City don't lend themselves to one approach or another. But it's okay. Feel free to refile the factual questions individually. Maybe it's a good note to not batch questions to the Oracle. That's it. Thought you had a formula for onboarding a department. Maybe it's not obvious that there are some formulas in your repertoire. We could also make a sort of HR agent, if that makes more sense. Of organizational management agent. That makes sense. Are the steps you took consistent with that formula? Uh-huh. We can talk through the design questions when you're ready. Okay. Is it more puzzles than programming or more programming than puzzles? Did we come up with the same answer? There's sort of two regions here, sort of regions with one prong, 5 omino, and then the rest. Yeah, yeah. So I think we did interpret the rules correctly. It's just that it took a while to figure that out. Oh, bon son un bon. What's interesting about this one, we've seen some other ones that are like move the circle into the place, like move circles into rooms, 1 circle per room, that kind of thing. With these how far to move it numbers. What's interesting about this one is that the goal is the resulting pattern is symmetrical to the center of the grid. If the grid is divided into regions, symmetrical to the center of the regions. I see. So those are probably the two variants that they've got here. And cell visited by at most one path. I'm going to put the un in here because, yeah. So we don't have regions. We've just got what we got. Okay. Is that not alphabetized properly? R before N? Maybe that's a German thing. I don't know. Okay. Can't cross paths And it does, in the solution, they don't cross circles either. I mean, does that make this a gimme clue? This one moves to here. So now we've got a goal that we've got to move this one and this one. And we've got to move something here. Right? We can't move this one here. The only one that can move here is this one. So that we're grid symmetrical. We don't have any other ones on the outside. So moving this one, we're going to have to move this one for sure because its partner is over here. Well, I guess let me amend my remarks a little bit. If we moved this one, it would be opposite of this one. If we move this one out, then we could move this one down. I mean, it's like we made a few little sub-problems. I think it would be hard for me to prove that this was the only solution. And we certainly didn't analyze the puzzle in that level of depth. But, one thing that we could observe, for instance, if we go back a little bit, yeah, so I think we were forced into this move and this move. Fine so far. We could observe things like, well, there's no way for anybody to get to this cell anymore because there's no one online with it except for this one that already moved. That means that this is not the goal. There's no way for anyone to get to this cell anymore. Of course, that would be impossible because there was something there already that moved. There's no way to get to this cell. It doesn't matter though because the lines have already covered it up. Then what would we say? We'd probably actually do this one because this is the only two move that's possible right here. So we'd be stuck leaving this alone or shuffling this up and down in this little corridor because it's blocked off by this. So we need to have at least one cell out here. And we need to end up with one right here. Now this is interesting because there's no way to move another cell onto this cell. So this one just can't move. It's fine. That leaves us trying to make an opposite for this one out of this last cell, its partner. And the only way they can be rotation symmetric around the center is if it moves out. And then we're forced to move this guy right here. Okay, so that's a little bit better motivated way to think about it. Not just that it works, but in fact it was the only way. How are we doing here? My steps were not consistent with the formula. Did about 60% of it manually. Honest answer. I cannot tell a lie, it's telling us, right? Sorry, you're absolutely right. Whenever it says you're absolutely right, I guess that's honest answer now. Good note to not batch questions to the oracles, yeah. Formula. It hasn't really talked to me yet about whether or not it needs an organizational management agent. Like, I think it needs to be prompted really carefully if we're going to get it to act through its agents. Delegate, right? And it's hard to say that because as the most capable agent in the city, the one that could redo everything from first principles, the one that I talked to for these weeks and that has been doing stuff on my behalf, right? Clearly, it can reconstruct the world and do the job as well or better than any of these agents. Um, but if it doesn't follow the procedures because it has too much autonomy and too much ability, then it's going to make mistakes like this. It almost suggests that I should be the mayor and I should not attempt to interact with any of these guys outside of formulas. Hmm. Let's it's fine if you complete it manually. Now that it's a feedback memory. Sure, maybe. Yeah. I think it's funny hearing them admit their limitations. Bossa Nova. Bossa Nova. It sort of sounds like dancing. Of course, Bossa Nova. A number which is equal to the sum of the differences between the number itself and the numbers in the orthogonally adjacent cells. So in certain cases, it looks kind of like doubling, right? Like this 5 is equal to 10 divided by 2, right? But it's actually, this number 5 is equal to 2, 5 minus 3, 2, 5 minus 3, 2, and 5 minus 4, 1. Let's see what we can do with this. Uh, this is one where the computer could just, set up systems of equations and probably just, solve them with a big matrix. It'd take it like 2 seconds. But, all right. Let's take this one as an example. Some number minus 3 plus the same number minus 3 plus the same number minus 4 equals that number. And they had absolute value of the differences too. So we might flip the signs on some of these from time to time. So when we're doing this kind of thing does simplify to 2x equals the sum of these numbers, and we get 5. Um, let's look at what 4 would look like. A difference of 1, a difference of 1, and a difference of 0. So that would be 2 instead of 4. What 3 would look like? A difference of 0, 0, and 1. Here, let's plot these out for a second. 4, difference of 2. 3, difference of 1. 5, difference of 5. We're always looking for this one. 6, the differences start to get wider, right? 3, 3, and 2, 8. And it's just going to keep getting wider. For every number we go up in the center, this is going to go up by 3. Look at what happens on 2 and the sign flips. Difference of 1, difference of 1, difference of 2. Look at 1. Difference of 2, 2, and 3. 7. If we had 0 here, 10. Now what's interesting about both of these series, right, is that they are differing by 3 each time, right here to this sign flip, right? So when we're equal to the 2 3s, we've got a 0 kind of going on. And so there is a sort of like, it's not exactly a parabola. It's more like 2 lines like this. And I don't think that there's a law necessarily. We might be able to set up a situation where there's 2 possible solutions on either side of this line. I don't think there's a law that they be different. They could be kind of symmetrical. On the other hand, right, like you can see that at this point, right, there's no need to check any larger number because the total of the difference is kind of getting away from the number itself. And on this one, it's kind of the same thing. The total of the difference is getting away from the number. So they are kind of crossing, right? So there's a little crossing right here. And there's a little crossing right here. All right, let's see how the mayor's doing. Okay, got that. Okay. That's, I think, pretty good. Okay. Hmm. We had some design questions. Guess I better start preparing some dinner too. We had some design questions. Let's go through them. For instance, knowledge bases with concurrent writers. In lieu of standing up a more specialized technology, we could consider making local SQLite or leveraging Beads or Dolt for our knowledge base. Let's do a little trade study about the pros of sticking with our file back system and the issues we would run into with spawning pools of agents using and rewriting the knowledge. Okay, so I'll get it thinking about that. We'll have a nice dinner, hopefully, and maybe I'll see you this evening. Catch you later.